As students, many of you are occupied with life in the university. In this talk, I would like to venture into life in the universe. We all aspire to make Harvard the best university on earth, but could it be the best university in the universe? This boils down to the fundamental question, are we alone? What you see on the screen behind me is not the motto of a dating site. It is the most fundamental question in science. Are we alone? There are many reasons to be modest. My mother used to tell me when I was a kid. But after 3 decades of being a professional astronomer, I can add one additional reason: the richness of the universe around us. Let me explain. Prior to the development of modern astronomy, we tended to think that we are at the center of the physical universe and that it's centered on us. The sun and the stars were thought to revolve around the Earth. Although naive in retrospect, this is a natural starting point. When my daughters were infants, they tended to think that the world centers on them. Their development portrayed an accelerated miniature of human history. As they grew up, they matured and acquired a more balanced perspective. Similarly, observing the sky makes us aware of the big picture, and it teaches us modesty. We now know that we are not at the center of the physical universe. Since the Earth orbits the Sun, which itself moves around the center of the Milky Way galaxy, which drifts in some random direction throughout the universe. So there is not really a center to the universe. However, many people still believe that we are at the center of the biological universe. Namely, that life is rare or unique to Earth. In contrast, my working hypothesis is that we are not special, based on the analogy with the physical universe. We are not special in general, in terms of our physical coordinates, and also not special as forms of life. And adopting this perspective implies that we are not alone. This principle of cosmic modesty implies that there should be life out there, both primitive and intelligent. And it has practical implications. If life is out there, we should search for it in all of its possible forms. We now know, thanks to the Kepler satellite, that about a quarter of all the stars in the Milky Way galaxy have planets like the Earth at the right distance from their star to have liquid water on their surface. And there are 300 billion stars in the Milky Way galaxy and 3 billion similar galaxies in the observable volume of the universe. So altogether, there are 10 to the power 20 habitable planets, roughly the size of the Earth, that could potentially have life. Is it reasonable to assume that life is only realized on our planet? Our civilization reached a milestone. We now have access to unprecedented technologies that allow us to search for both primitive and intelligent forms of life. And both of them exist in the one example where we find it, here on Earth. The search for primitive life is underway and well-funded. But the search for intelligent life is out of the mainstream of federal funding agencies. This should not be the case, given that the only planet where life is found to exist has both primitive and intelligent forms on it. There is no doubt that noticing the big picture taught my young daughters modesty. And similarly, the Kepler satellite provides astronomers with a perspective that there are many habitable Earth-mass planets out there. There are more such planets in the observable volume of the universe than there are grains of sand on all the beaches on Earth. And if you think about an emperor or a king in the history of humankind that used to boast about conquering a piece of land here on Earth, that person resembles an ant that hugs a single grain of sand on the landscape of a huge beach. the chemistry of life as we know it requires liquid water. But being at the right distance from the star is not sufficient to maintain life. One needs to have an atmosphere, because without an atmosphere, if you warm up water ice, it will go directly into a gas phase, not into a liquid. So to have liquid water, you really need an external pressure of an atmosphere. And the warning sign for that can be found next door. Mars. It has 1/10 of the mass of the Earth and has no atmosphere right now. And we don't see life crawling on its surface. But rather than being guided by Fermi's paradox, where is everybody? Or by philosophical arguments about the rarity of intelligence, we should invest funds in building better observatories and searching for a wide variety of artificial signals. And these signals need not be just communication, radio signals. They could be artifacts on the surface of a planet. Our civilization could produce mostly weak signals. For example, a nuclear war would not be visible on the nearest planet to us, even if we were to use our best telescopes. But very advanced civilizations could potentially be detectable out to the edge of the observable universe through their most powerful beacons. The evidence for intelligent civilization could be in the form of pollution of the atmosphere, if they're not very intelligent, could be in terms of artifacts on the surface of the planet, and beams sweeping across the sky that are used for a variety of purposes, such as propulsion of spacecrafts. Once formed, extreme forms of life, like tardigrades, would survive astrophysical catastrophes, like exploding stars nearby and so forth. Tardigrades, these tiny water bears, are known to survive extreme conditions. Some of them were put in space and survived the journey for over a week under extreme dehydration, cosmic rays, and so forth. So they could, in principle, serve as tiny astronauts if they happened to lie on the surface of a rock or deep in the interior of a rock that was thrown out of a planet, so they can transfer life from one planet to another. Just over the past year, astronomers discovered a habitable planet around the nearest star, Proxima Centauri, and also a system of 7 planets around another star that is 40 light years away, called TRAPPIST-1. You can see its planets above me. 3 of these planets are just in the habitable zone. They are rocky planets that could have liquid water on their surface. We don't know if they have life on their surface. This star is 8% of the mass of the sun. And so it's much fainter, and the habitable zone is 20 times closer to the star than the Earth is from the sun. And you can see here the Earth and the 3 habitable planets around TRAPPIST-1. Now, TRAPPIST-1 is an example for a dwarf star, about 1/10 of the mass of the sun. And such stars are the most common in our galaxy. And they live for 1,000 times longer than the sun. The sun is roughly at the middle of its life right now. And such stars will live for trillions of years. The first stars formed when the universe was much younger than the current age, about 100 million years after the Big Bang. So we might ask ourselves, why is it that we find ourselves today next to a star like the sun, and not in the distant future next to the much common population of stars that are much smaller than the sun? Where does the likelihood of life peak in the history of the universe? So if one allows for life to exist around dwarf stars, they provide excellent prospects for life in the distant future. And when you plot the likelihood of life as a function of cosmic history, it actually peaks trillions of years from now, and you can see it in the rightmost curve above me. On the other hand, such stars may pose risks for life, and it's quite possible that only stars like the sun allow life as we know it to exist. In that case, we are just at the right time where the likelihood for life peaks, when the age of the universe is comparable to the lifetime of the sun. And the good news is that the possible existence of life around long-lived, low-mass stars can be tested observationally. We can just look around us and search for life around those stars, and then figure out if indeed stars like the sun are much more hospitable for life. So the closest star to the Earth, Proxima Centauri, is only 4 light years away. It takes light 4 years to get to us from the nearest star. And it's a member of a triple system. There are 2 other stars in that system. It's called Alpha Centauri. And the 2 other stars are just like the sun. Proxima Centauri is 12% of the mass of the sun. And amazingly, a habitable Earth mass planet was found around the nearest star, Proxima Centauri. Because the star is so light relative to the sun, the habitable zone is much closer in, 20 times closer in. And this planet orbits around Proxima Centauri every 11.2 days. So if you were to live on that planet, you would celebrate a birthday every week and a half. You would also need infrared eyes, because this star is bright mostly in the infrared. But to have life as we know it, one needs liquid water on the surface of this planet. And to have liquid water, one needs an atmosphere. So does Proxima b, this planet near us, outside the solar system, does it have an atmosphere? We don't know. It was just discovered a year ago. How can we find out? One way to do so is to look at the temperature contrast between the side facing the star and the other side. As it turns out, this planet is so close to the star that it always faces it with the same side. So there is a permanent day side and a permanent night side. The permanent day side is hot. The night side is cold. The temperature contrast between the two depends on whether there is an atmosphere or an ocean, because these components moderate the temperature contrast. If you have just bare rock, the temperature difference could be quite large. So how can you tell? Well, as the planet moves around the star, you see different phases of it. And so you can monitor the temperature that you see as a function of time. And over an 11.2 days period, you can figure out what the temperature contrast is between the 2 sides of the planet. And that will tell us whether it has an atmosphere or not, because we can calculate the temperature contrast for bare rock at that distance from that star. And as it turns out, the James Webb Space Telescope, to be launched in 2019, will be able to tell us whether the temperature contrast excluded an atmosphere around this planet. A cosmic perspective about our origins would contribute to a balanced worldview. The heavy elements that assembled to make our body were produced at the heart of a massive star that was nearby and exploded. A speck of this material took the form of our body takes the form of our body during our life, and then goes back to Earth. With one exception, namely the ashes of Clyde Tombaugh that discovered Pluto were put on the New Horizons spacecraft and are making their way back to space. The rest of us return to Earth. What are we then, if not just a transient shape that the speck of material takes for a brief moment in time over cosmic history on the surface of one planet out of so many out there? Despite all of this, life is still the most precious phenomenon that we cherish and treasure here on Earth. It would be amazing if we find evidence for life as we know it on the surface of another planet. And even more remarkable if our telescopes will trace evidence for an advanced technology on an alien spacecraft roaming through interstellar space. Thank you.